Today we're going to be talking about scale drawings and scale models, and so I have a couple definitions for you here. A scale drawing is a drawing with accurate sizes that have been reduced or enlarged. So some examples would be a map, a blueprint, or things of that nature where in both of these cases things are scaled down. So everything is drawn accurately to each other, but it's scaled down or enlarged to do that. A scale model is different than a drawing because it's a 3D display. It's an actual model with accurate sizes that have been reduced or enlarged. So everything gets reduced or enlarged the same way. So some examples of that might be a dollhouse, a toy car, etc. And so both of these scale drawings and scale models have a scale. And this scale is the amount that a drawing or model is reduced or enlarged. So a scale could be something like 1/4, where 1 inch is equal to 4 feet. We always, when we're writing scale, want to put the model on top and the actual on bottom. So whether we're reducing or enlarging, the model always goes on top and the actual is always on bottom. So if my model gets bigger, my top number will be bigger than my bottom number. If my model gets smaller, or my scale drawing gets smaller, my top number will be smaller than my bottom number. So when we open this up then, we're going to use scale now to find some dimensions and distances. Part A says, on a road map with a scale of 1.5 inches is equal to 60 miles, the distance between Pittsburgh and Philadelphia measures 7.5 inches. What is the actual distance between the two cities? Think first, which is bigger, the distance on the map or the real distance? In this case, that would be the real distance. And then what is the question asking? What unit should you put on your final answer? It's asking for actual distance. It's asking for the actual, and it wants it in miles. So the actual miles is what it's asking us for. So it says write a word fraction to help you put all the numbers in the right places. We're going to set up proportions just like we did with similar figures. So the first thing I'm going to set up is the scale as a fraction, 1.5 inches over 60 miles. I'm going to use it with words or with labels to help myself. And that's going to be equal to, this distance is 7.5 inches over, we don't know miles, so I'm just going to put an M for miles. I'm going to put in a variable M. And so this word fraction, this word proportion, helps us actually write and solve another proportion. Think about which is the model and which is the actual. Our model is our map, our actual is in miles. So our proportion without labels is 1.5 over 60 equals 7.5 over M. From here I can use cross products to solve. 1.5 times M is 1.5 M. 7.5 times 60. I'm going to pull out my calculator to help me, is 450. The inverse of multiplying by 1.5 is dividing by 1.5 on both sides. So I do that and get 300. M equals 300. And so the answer, the distance between the two cities is 300 miles. Go back to number 1 and make sure your answer makes sense. Are the units correct? So up here where we were thinking about which one is bigger, is our distance in miles bigger than how many inches it was? Yes. Did we find the actual distance? 300 miles seems reasonable between two cities. And did we label it with miles? We did, and so our answer seems reasonable and makes sense. So we have one more problem like this where we're talking about a blueprint. And it says a blueprint of Eric's house uses the scale 1/4 inch equals 1 foot. If Eric's dining room is 18.5 feet long, how long is it on the blueprint? Think first, which is bigger, the blueprint or the real dining room? In this case, the real dining room is bigger. What's the question asking us for? It's asking us for the blueprint length. How long is it on the blueprint? And so our units, in this case, remember that we've got our model to our actual. In this case, our model is what we're finding, so our label is going to be in inches. The next thing says write a word fraction to help you put all the numbers in the right place. So first I'm going to write my scale as a fraction. So that I don't have a fraction within a fraction, I'm going to convert 1/4 to a decimal, and I can do that by dividing on my calculator, or you may just know, you may think about fourths as quarters. 1/4 is equal to 25 cents. So we've got 0 and 25 inches over 1 foot equals the blueprint's length, which we don't know, b inches, over how many feet is the actual dining room. It's 18.5. So I'm going to write that as a decimal as well so that I don't have fractions within fractions. And then I'm going to write and solve a proportion. I'm going to use this word proportion to write it with just numbers. 0 and 25 over 1 equals b over 18.5. I use cross products to solve. 1 times b is 1b, or just b. 25 hundredths times 18.5 is equal to 4 and 625 thousandths. And so the answer of the dining room is 4 and 625 thousandths inches long on the blueprint. So the other answer that we could have here, if you know fraction and decimal conversions, or if maybe you didn't convert and you used fractions, would be 4 and 5/8 inches. I would accept either answer on a test or quiz. And then it says go back to number 1 and make sure your answer makes sense. Are the units correct? Does it make sense that if it's 18.5 feet long in real life, that it's 4 and 5/8 inches on a blueprint? I think that seems reasonable. Is our label correct? Is this, we said we were looking for inches, we found inches, b inches. Yep, so our labels are correct, our answer checks and makes sense. And it's really good for us to go back and do that at the end of every problem, double check and make sure that our answers make sense. So to start today, we've defined scale, and what scale is. We've defined scale drawing and scale model and distinguished the difference. Scale drawing is a 2D map or blueprint. A scale model is a 3D display. So, and then we did 2 examples where we were using scale drawings to find missing lengths, either on the drawing or in real life, based on a scale, a fraction that we were given to represent that situation.